So this next problem has both a parentheses and a fraction in it. Notice the steps say to distribute first and combine like terms if you can, then get the fractions. Step 2 says get rid of the fractions by multiplying by the LCD. So I need to distribute first because that's the order of our steps. So I'm going to take this 1/3 times 5x and then times 2. Remember, it's easier to multiply fractions to other fractions than fractions to whole numbers. So I'm going to make the 5/1 and the 2/1. I have 1/4 plus 5 times 1. I'm multiplying the numerators and get 5. 1 times 3, and that's 3. Multiply the numerators. 1 times 2 is 2. 1 times 3 is 3. Equals -2. And actually, I'm going to make the -2 a -2/1. Now, I know the 1/4 and the 2/3 can be combined, but I really don't want to have to deal with fractions, so I'm going to move on to step 2. I'm going to get rid of all of the fractions by multiplying by the LCD. The LCD between 4, 3, 3, and 1 is 12, because 12 can be divided by 4, 12 can be divided by 3, 12 can be divided by 3, and 12 can be divided by 1. So I have covered all of my denominators. Because there's an equal sign in the problem, the multiplicative property of equality says I'm allowed to multiply every term on the left and every term on the right by any number I choose. I choose the LCD. The reason I choose the LCD is because it's going to divide out real nicely. 12 divided by 4 is 3, and then I have just 3 times 1 is 3. 3 and 12 divide 4, and 4 times 5 is 20x. 3 and 12 divide into 4, and 4 times 2 is 8. And 12 and 1, that's still just 12, so -2 times 12 is -24, divided by 1 is still -24. In one step, I was able to get all of those fractions to turn into whole numbers. Now, if you don't like this canceling bit, you don't necessarily have to do that. Let me show you one other way you could think of it. I'm just going to rewrite this to the side. If you multiply everything by 12, and you don't like the whole canceling, because it does get a little messy, right? What you could do is do 12 times 1 is 12, divide by 4, and that still gets you 3. So just multiply the tops. 12 times 5 is 60. 60 divided by 3 is 20. 12 times 2 is 24, and 24 divided by 3 is 8. And 12 times -2 is -24, and -24 divided by 1 is -24. So there's another way of doing it without all of the slashing that maybe is a little bit neater. Either way, it still works. So I'm going to combine like terms now. The 3 and the 8 are like terms on the same side of the equal sign. So I get 20x plus 8 plus 3 is 11. I'm going to label the x's to be the left and the numbers to be on the right. So who is on the wrong side? Well, it looks like this 11 is on the wrong side, so I'm going to subtract 11 to both sides. And that gets me 20x is equal to -35. And -35, let's see, the 20x is, the x isn't by itself because the 20 is in the way, right? So what I'm going to do is I'm going to divide both sides by the 20, which is the fourth step. Use the multiplicative property of equality to get the 20 away from the x. And now the coefficient is 1, which is what I want, equals -35 over 20. Now, -35 20th reduces if I divide the top by 5 and the bottom by 5, which leaves me with x equals -35 divided by 5 is -7. 20 divided by 5 is 4. -7/4 is my answer. I don't have enough room here for the check. I'm going to let you do that one on your own. Our next problem, we have a lot of distributing to do, so I'm going to distribute over here. That's 24x plus 3. Distribute the -5, -20x minus 5 equals 5x plus 9. Looks like there's some combining to do on the left. So on the left side I have 4x, and the numbers Negative 5 plus 3 is negative 2. On the right hand side, 5x plus 9 doesn't combine at all, so that just stays 5x plus 9. I want to label one side to be the x side, so I'm going to put the x's on the left and the numbers on the right. And let's see, on the left, the negative 2 is in the wrong spot, so I'm going to add 2 to both sides. At the same time, the 5x is on the wrong side as well, so I'm going to go ahead and subtract 5x from both sides. I'm going to do basically 2 steps in one. The negative 2 plus 2 add to 0. The 5x minus 5x add to 0. So 4x minus 5x gets me negative 1x on the left. 9 plus 2 is 11 on the right. And I've successfully got all the x's on the left and all the numbers on the right. And now I want to get the x all by itself. To get the x by itself, I need to do the opposite of multiply by negative 1, because there's a negative 1 being multiplied to the x, and I want to undo that. So I divide by negative 1. Negative 1 divided by negative 1 is positive 1. 11 divided by negative 1 is negative 11. And so my answer is x equals negative 11. Again, I'm going to leave the check to you. On this next problem, we have lots of parentheses. We want to start for the innermost. So when I distribute the innermost parentheses, I'm getting 4x plus 2. I'm going to go ahead and distribute the right side as well, 15x plus 10. I can combine like terms inside the parentheses, so that gives me 4x plus 6. I usually like to put the x in front, so that's why I put the 4x first. Technically, it doesn't really matter. And I still have parentheses. I'm still doing step 1. I distribute that, and I'm getting 12x plus 18 equals 15x plus 10. All right, so now I want to label one side to be the x's and the other side to be the numbers. Again, it doesn't really matter which side you pick, but labeling it might be a good idea. On the x's, it looks like 15x is on the wrong side, so if I subtract 15x, I'm going to go ahead and put that right up under the other x on the other side. It looks like on the number side, 10 is on the right side, but 18 is not. So if I subtract 18 from the left, I then should also subtract 18 from the right. We always keep things fair. So 12x minus 15x, that gets me negative 3x. 10 minus 18 is negative 8. In the very last step, I'm trying to get rid of the negative 3 because I want x to be all by itself. To undo a multiply by negative 3, I'm going to divide by negative 3. The whole process is to get x all by itself. So a negative divided by negative is a positive 8/3. And that is our answer. This concludes our lesson on solving linear equations.